All right, so these are the notes for handout 5.5B on cross multiplying. I don't think this is going to be any great difficulty for y'all. When we did our solving equations unit right before exams, we kind of didn't really quite finish everything. So instead of doing it in January, and I decided to stop and make it a little blip in the middle here. We're going to do the worksheet you gave me already. We've got 3 more, and we're going to have a quick quiz. Right now, I have it scheduled for Friday, but considering that half of you are not here today, we may change that, okay? I'll think about that and put that. It might not be until Tuesday, okay? Just to give everybody a little bit more time. Okay, so cross multiplying. I'm going to let y'all use your calculators on this, but you still have to write down a reasonable amount of work. So the first thing is to remember what it means to cross multiply. And I've written the statement sideways here, which I'm not a fan of. I actually like it underneath, but this made it take up a little less room. I know I see people do cross multiplying a lot. I see people do this. Y'all remember doing this cross multiplying? That's the A times D. And then the crisscross over here, and that's the B times C. And we're going to apply that now to problems that have variables and numbers in them and use it as a specific technique for solving an equation, okay? So some of these are super easy, and I will also warn you that some of them have weird fractions because I can make up a problem really quick, but making up a problem that doesn't have a fraction for an answer takes a little more time than I just didn't fool with it too much. So we're going to solve by cross multiplying. So 5 times 9, which is 45. Yes, 5 times 9 is 45 here. And then we're going to go this way. Don't put so much work on it. Here's the sharper blades. Okay. 3 times 2x is 6x. And now we are at the point where you just solve by dividing both sides by, okay, dividing both sides by factors. I'm going to let you use it. I want you to use it efficiently and effectively. 45 divided by 6. 7.5 is a perfectly fine decimal to write down, or if something in the instructions suggests to you that I would prefer fractions for an answer, push math 1 on your calculator and get 15 over 2. Both answers are fine. Okay? All right, second example, you do not have to draw those circle things on the problem. Just make sure you always multiply across. So it's 12 times 1. I've also seen people do it like this. 12 times negative 1. And then 4 times A. This is another way I've seen people write it. I just don't like so much on there that you can't read the problem, okay? Which I think with your pencils is probably okay. And divide both sides by 4. And A equals -3. Cross multiplying is really effective when you have a variable in the denominator. It's not the only way to deal with a variable in the denominator, but it's often the best way. When you're trying to solve and the variable's down underneath that division bar, you got to get it up to the top. And by cross multiplying, that automatically brings all the denominators out of there, and you don't have to fool with them. So 5 times 10, 50, right? And x times 1 is 1x, and I'm finished. X equals 50. I don't even have to divide by anything. Okay? Do y'all see how that process gets the x out of the denominator? Okay? All right, and this next one will be maybe a little bit longer. I'm going to stop drawing these things in a few minutes. -5 times y and 3 times 1. You can stop whenever you want to. It's not necessary to draw them. And then divide both sides by what? 3 or by -5? By -5. Okay, so again, grab that calculator. 3 divided by -5. -0.6, and a lot of us like to put 0.6 just to make sure you don't lose the decimal, or change it into a fraction and get the answer -3/5. Okay? Super easy. You probably did it all from somewhere in your past. Okay? The next set of examples requires that we use parentheses effectively. Okay? So when I multiply 8 times x minus 4, if you write this down, that doesn't say 8 times x minus 4. It says 8 times x. I have to say 8 times all of it. So this is where you have to put the parentheses in. 8 times x minus 4 in parentheses. All right? And then in the other direction, I can't read it. 2 times 3 is 6. So this is just not hard, it's just got one extra layer of complexity to it, and we do stuff that we already know how to do, distributive property, 8x minus 32 equals 6. Add 32 to both sides. Can I get a show of hands of how many of y'all are not writing this? Who is not writing this on their paper at this point? Anybody? Everybody still writing it? That's fine. It usually keeps you from making quite so many mistakes when you write it there. Okay? I'm going to skip it though because I'm out of room. So 38, is that right? 8x equals 38. Divide both sides by 8. Give me the decimal, 4.75, and what's the fraction? 1904. Okay. All right, and let's try this next one. The same process. 3, you need parentheses. 3a plus 1, and 4 times negative 5 is? Negative 20. I'm going to say again, you have to use your calculator for this. So those of you who know that your arithmetic skills are a little weak, get good with that calculator, okay? My spelling's a little weak. I used to say, so I'm good with the dictionary, and now I say I'm good with spell check all the time, okay? All right, 9a plus 3 equals negative 20. Subtract 3 from both sides. 9a equals negative 23. And I think this is going to be you're not going to be allowed to write this decimal down. Take a look at it. Isn't it one of those long, horrible looking decimals? So that answer, I'm not interested in that answer. In science class, you have some rounding rules and you would apply it, but in here, I don't want it, so you're going to have to give me the fraction answer for that. Okay, can I get somebody to tell me, can you see the difference, in 5 and 6 compared to 7 and 8? Do you see anything that seems different, Caroline?
On the right side, it's a whole number.
On the right side, it's a whole number. So we're going to put negative 3 over 1. Okay, you see something else, Jayla?
The variables at the bottom.
The variable's at the bottom, and it's not just an x, it is an x plus 5. Okay, so we're going to pick these two things into this puzzle. We're going to say 1, this one right here, times that negative 2, which is going to give us negative 2. And then when we go in this direction over here, we have to say negative 3, and there our parentheses come into play again, negative 3 times x plus 5. Does everybody see? Okay, it's all the same thing, cross multiplying. Great chance if you remember doing cross multiplying before, in some fashion or another. Okay. All right, negative 2, negative 3x minus 15. Negative 2 equals negative 3x minus 15. What would you do next? What would you do next, Lindsay? I would add 15 to both sides. I think I'll have plenty of room for this. Mine just feels a little squishier. I'm just going to erase that. And 13 equals negative 3x. Divide both sides by negative 3, not by 13, by negative 3. And I think once again, we're going to get a fraction that we don't want to write that decimal answer there. Okay, 4.33333. You need to change that math 1 and it'll change right away for us. Okay? All right, so I'm going to pause for just a second. I want you to try example 8 on your own. Okay, I'm going to show just the smallest amount of work for these. 4x equals 3 parentheses x plus 1. Everybody check for those parentheses. 4x equals 3x plus 3. Don't forget that your distributive property there is not 3x plus 1, it's 3x plus 3. And then this one came out nice. You subtract the 3x from both sides, and we get x equals 3, and we're done. Okay? All right? Okay. Example 9, this time not only is the x in the denominator on one side, but it's also in the denominator on the other side. So when we Cross multiply here, you just need to use your parentheses on both sides this time. So the first crossing will get -1 times parentheses x minus 3, that's this one, okay? And on the other side, it'll be 4 times x plus 2. So it's not really any harder, just a little bit more complex, a little bit of extra work, but not really hard. Watch out for your distributive property. When you multiply by -1, it just changes the sign. So we'll go to -x and a plus 3. And then we'll multiply by 4. And y'all can go ahead and finish that one. I think this one does not come out to be a fraction. I believe I managed to get a few of them not being fractions. Anybody else get -1? If you did not get -1, can you mark the problem, and in just a minute I'll look and help you find what your mistake was, okay? If you did not get -1. Okay. All right, and the last one, notice that there's x's in the numerator here and also in the denominator. And this is another really good place for using cross multiplying. We've got to get that x out of the denominator. And it also has that business over here on the right where this is a whole number. So what do we have to do for a whole number if we need to cross multiply? What do we do with it? Put a 1 in the denominator. Put a 1 over 1. If it were a 5, put it over 1. If it's a -3, put it over 1. And then we get to multiply by 1, which makes everybody very happy. Yes? Technically, it's 1 times 2x minus 1 and 1 times x. But realistically, since you're multiplying by 1, you probably would just write that step down. You probably actually would skip that first step, but be prepared to do it if you need to. Okay? Every once in a while, I have somebody who does this. I want y'all to all look up here. This is a perfectly fine thing to do. Right here, there's nothing wrong with this. But can everybody look? I just trying to help y'all avoid a mistake. 2x minus x is x. And -1 goes there, and there's nothing over here. Now watch, here's my mistake. Watch, this is what people do. They go, oh, there's nothing there. And then they make that an equals instead of a minus. Okay? That's a -1. You cannot change a minus into an equals. You have to put down what you get when you subtract x minus x. What do you get when you say x minus x? 0. You have to put it there. Okay? If you're going to go in that direction. And then add 1 to the other side. Okay? And so just watch out for that careless mistake. All right, everybody follow? Okay, I'm going to pause this and let it save if I can find it. There it is.